to continuing to study the Uniswap. I don't think I'm gonna spend too much time here today. Maybe I will after, because I have to train, go to the gym a little bit, so maybe I will come back later, but there's also a lot of stuff that I want to do off stream, so maybe I'll just spend 10 minutes training with him. And I'm gonna I'm gonna study the stuff that I said that I was gonna study. I'm gonna follow this list here. But before I do that, I'm gonna do the Italian thing. And train with him for 10 minutes.
Io,
Io,
I,
il suo,
il suo,
his,
che,
that,
lui,
lui,
he,
era,
era,
he, she was,
per,
per,
for,
su,
su,
on,
come,
come,
as, like,
con,
con,
with,
loro,
loro,
they,
essere,
essere,
to be,
a,
a,
at,
uno,
uno,
one,
avere,
avere,
to have,
questo,
questo,
this,
da,
da,
from,
di,
di,
by,
caldo,
caldo,
hot,
parola,
parola,
word,
ma,
ma,
but,
cosa,
cosa,
what,
alcuni,
alcuni,
some,
è,
is,
quello,
quello,
that,
voi,
voi,
you, place,
o,
o,
or,
aveva,
aveva,
had,
il,
il,
the,
di,
di,
of,
a,
a,
to,
e,
and,
un,
a,
in,
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 noi,
noi,
we,
lattina,
latina,
can, of soda,
fuori,
fuori,
out,
altro,
altro,
other,
erano,
erano,
were,
che, quale,
che, quale,
which,
fare,
fare,
to do, make,
loro,
loro,
there,
tempo,
tempo,
time,
se,
se,
if,
volontà,
volontà,
will,
come,
come,
how,
detto,
detto,
said,
un,
an,
ogni,
ogni,
each,
dire,
dire.
tell,
Very nice. I'm gonna do the film. I think I'm gonna build something in Python to read PDF files, because there are a lot of it's not even books, maybe papers and books that I want to read. So I'm thinking about doing that. So I'm not sure if I'm gonna do that off stream, or I might do it on stream. And that's one of the things that I'm planning on doing today. And also reading stuff from websites as well. I think this is a new one. It marks. Also new. don't understand what is a bookmark position, but whatever. And this one doesn't look like it's gonna be that hard actually. So I think I can go fast through this one. It's mostly repeating the stuff from the previous one. Oh, I was gonna get that one, I think. Oh no, it's a different one. Mark positioning. Remove. Routing. Oops. Oh, it's Control G. I was confused that one. Oops. I think this is a new one, maybe. I don't remember this. Maybe it's Control P, but oh, it's a new one. Okay. This one is the Mark one. Oh, it's not. This is the Mark, probably. But maybe not, actually. Or marks. Yeah, show bookmarks. This. No. Hmm. I'm not sure which one was that one. How to write that character. I kind of forgot. Not sure if it's the single comma or the other one. Uh, oh, M A. This is the one that I'm not sure. Okay, is the single comma. It looks like it is the other that I don't know the name, the other special character, but it's just a single comma. This oh, maybe it's MA, this one. Ah, there we go. Nice. Oh, fuck. Previous position. And this is this one. I think I'm gonna test after the 10 minutes. It feels like, but maybe I don't remember some of them, so. But I think the way that this was designed is more for you to test quickly because on the next level it repeats a lot of the other ones from the previous one. Which bookmark position? Yeah, nice. Which at the beginning I didn't know, so I think I spent too much time on a particular level, but I should just go faster through them because I think it's probably better. Since a bunch of the keywords are repeated from level to level, which makes sense. Because we want to get the space repetition. Oh, this one is marks. Yeah, I'm gonna test to see if I pass. There. And then I will start studying the smart contracts or the projects from Uniswap. This one is the one that I'm always getting twisted. Visual modes. I think this is the lowercase v. I'm not sure. And this one doesn't let me get right, but I know that is the semicolon. Oops. I think it's this one, but I'm not really sure. And this one has to be the caps lock one. It's Control G, I think. G. This one is okay. So this one I got it incorrectly. Zeme. Yeah, I forgot about that one. Well, the rest I passed. So I think next time I'm gonna go with this one. Hopefully I can finish this in the next 3 days. 1, 2, 3. And then I'll go back, do each one time. And then the later ones that I didn't practice much, I'm gonna spend. I think I wish there was a counter there so I can know how many reps I put in. But I think I'm gonna put some time on each one and do just a bunch of repetitions before I go and start the other shortcuts. I think I wanna do terminal and then uh PyCharm later because VS Code I kinda know some things, even though I also wanna do VS Code as well. So now let me get you this. So the first one is QuoterV2. So yeah, I was looking at the SDK before I streamed about this. It looks like it's just a file with the interfaces, and then it has something about the pools. I think the utils are the ones that have the functions, or the entities and utils, and these ones are just interfaces for the SDK. This is just a function from Ether's project that allows you to get the address by of the address you would get by using the create true function on the smart contract. And create true is an OP code on smart contracts. I remember looking at it, but I don't remember exactly what it does. But I remember that I searched for create true at some point. I'm curious to see the multi-call, and I'm also curious to see the smart contracts as well. It doesn't look like the SDK has that. I think it's just the interfaces, which is a little bit weird actually. But I guess it's importing the other projects. So so I think I'm gonna look at the contracts, smart contracts. Hopefully on the core. And maybe let me start with the thing that I said that I was gonna start with. So I'm gonna search for the QuoterV2. Oh, this is also interesting. So they actually created this type. It doesn't come from Solidity. Encode the number. Never overflows. Okay, next one. I don't think I wrote it down where it came from. Or maybe it's on the smarts, the router stuff. Yeah, I think it's on the router. This one. Yeah, so the SDK is the project that contains the files that get the abstractions from the contracts, I think. and the periphery in the car has the contracts. That's how it's organized here. Oh, there we go. So QuoterV2. Let me read the stuff that I wrote here again. And this was the function that I was just looking at before. UniswapV3Pool. Gets all base currencies compared with token A and token B, computes them based on V3 factory address, then use multiple contract single data to get slot 0 and liquidity of the pool addresses compared to pool state interface. Returns the pool based on cash. If not cached, gets it from V3 SDK pool class. Which I think it was the class that I was looking at just now. Calls Uniswap API, also uses smart order router project. But I didn't wrote anything more specifically. I think I remember though. I remember seeing this and the routing stuff, but I don't remember which one was using this quoter to get the quotes for each pool, I think, or each token. Maybe it's pool, each pool. Where does this come from? Probably has to come from one of these contracts here. I think, yeah, it comes from this one. I think I just wrote it down here. Periphery payments with maybe comes from this. Oh, let me see if I can use the tool that I have here. The other thing that I was gonna see is, yeah, I can't really find a file like this. So edit visual. No, I don't know. I don't remember which one I'm supposed to use to visualize the graph. I think it's the call graph, but I'm not sure. Let me just try this one. Nice. Okay, it works. And this is the file. And this is actually super useful. The other thing that I want to study is account abstraction as well. I was looking at some videos before streaming, and I want to study that more in depth because I understand the concept, but I don't really understand how it works in practice and how to implement it, and also the zero knowledge proof algorithm, not just the concept. Also think it's gonna be really interesting to study that and probably really hard to find information about it. Okay, so this goes to the get pool and then UniswapV3Pool. So compute address comes from the UniswapV3 pool as well. Or maybe not actually. This is pool address here. Maybe, yeah. I was gonna say, I wonder if there's a way to change the colors of each one. There's probably a way to do that. Okay. If I click on it, it highlights, but I want to change the color of the arrows so it's easier to see. But I guess that's fine as well. Decode first pool, non-pools, has multiple pools. Then what is this? Yeah, this is all the counting logic for the ticks. Type. Slot 0. I don't understand really well what is this slot 0. I think it's something obviously to do with the OP codes in Solidity, but I don't remember really well. I think it's the first thing that is saved on the contract, or the first space, if I remember. I know there is the M load, I think, or something like that, which you have a star and then something else that I remember reading from the articles of the smart contract, but I don't really remember this thing exactly what it is. Yeah, so looks like they both activate the same functions, but they pass through other layer here. Code exactly input single. Hmm. Whatever. Create callback. You want to look at the functions now. Already got the idea. This is what gets activated after the get exact code, I think. I'm gonna look for this. Okay, so the X40 is the memory pointer, which I've seen here. So it adds the reason to the memory pointer. I don't understand why they would use assembly for that, but scratch space can be used between statements. The zero slot is used as initial value for dynamic memory arrays and should never be written true. The free memory pointer points to 0x80 initially. So it's used as initial value for dynamic memory arrays. So it always places new objects at the free memory pointer and memory is never freed. This might change in the future. Elements in memory arrays in Solidity always occupy multiples of 32 bytes. So I guess I understand, but I don't understand why would they use that. One idea that I'm thinking about doing is creating a new file and then adding all the contracts into one file and replace the import statements, and then using the visualization so I can see the connection between all of them. But I'm not really sure if it's worth it. Okay, so this is the function that comes before. So based on the visualization stuff, first activates this function, then this function gets the pool, and that function, the pool and the other functions activate the UniswapV3 callback, I think. Stores the amount received through the pointer. Where is amount received? Here. And the other thing I can do later is deploy this on a cheaper network, like or a testnet maybe, and then play around with this as well. It's also an idea. I don't understand where this type comes from. Uh, If it doesn't come from another contract, it has to come from another contract because this is definitely not something from Solidity. So, yeah, I'm gonna assume that it's coming from another contract. And that's where the call is made. Get pool. I guess that's the problem because in Solidity files the VS Code shortcuts don't work. So it's not gonna take me to the previous contracts. The other contract that has this function. Oh no, it's here. And this goes to the UniswapV3 pool. So I'm gonna open the other, this one, UniswapV3 pool. Some V3 core interfaces. I also don't understand how this is possible, so maybe I'm probably gonna look this up. Also, slot 0 is not from Solidity, it's from this contract. I was gonna say, how is it possible that it's calling the interface and not the contract itself? So I should probably study that again.
Hit log out. Boom. Okay, just like that.
I'm gonna watch videos about this later. Is this a bug or it's supposed to be like this? 'Cause I think this thing here should be here, but I'm not sure if it is just from this contract or the official one. Not sure what's going on here. Also don't understand why 96. What does this number mean? Yeah, let me move it to this one. Damn. It's gonna be tough. So these are just the contracts I think that it is importing. And then it has the functions that it is importing, maybe. Not really sure. Yeah, one of the reasons why I want to study account abstraction is because of the thing that if you have a wallet and you lose your keys or whatever, then the money is lost forever. And I think from the video I was seeing about Vitalik talking about this stuff is that you can use account abstraction, which is a zero knowledge proof, which it allows you to create a multi-sig wallet. And a multi-sig wallet is pretty much a wallet that has multiple different owners. So when one person loses their thing, they can talk to different people and then they can recover the wallet. And there's also maybe a way to stop. Let's say your wallet got stolen. There's a way for the other people to stop your wallet from working, I think. But I didn't understand too much. I didn't go too in depth into it yet. So, but I really wanna understand that. The other reason why is because I think you can deploy smart contracts with accounts abstraction and without paying the fee. Initially, you can do atomic transactions, and this is also seems really interesting. But I don't think because the thing that I was thinking about, I just thought about this because I saw the owner here, is how they decided which person is gonna have this owner address that is gonna be able to call different functions on applications like this because it seems that it's too insecure to because in a normal company if someone is the owner and they die or something happens to them obviously the whole thing is not lost, but in cases like this where you're building applications on chain, if you leave all your contracts for only being able to be accessed by only owner modifiers, and then for some reason the person that has the wallet loses the wallet, then you have to change the entire application, and it doesn't make sense to be structured like that. It's too fragile in my mind, so there's probably better alternatives. Now, obviously, I think Uniswap is a DAO structure, so it's different as well, but it's also something that is interesting, which even if it is a DAO, how is the structure of the thing created for being able to give privileges or not to people for them to access the specific functions in the contracts. So it talks to the oracle to get the price probably, the cumulative price. Binary search. I think I've seen this before, even before I started studying the interface. Something with binary search on the contracts. Oh no, what have I done? You just press this. How can I come back? Fuck. Maybe if I click here, no. I think I accidentally clicked there and then highlighted, but now I don't know how to unhighlight. I'm not sure if this is the correct way to say it. Okay. This no delegate call thing is probably for preventing some hacks. So it might be interesting to think I'm gonna write it down as well.
Some developers are afraid to use delegate.
So the QuoterV2 is the one that I just looked at. And reverts, get pull. So the slot 0 has current price, current tick. I don't understand why there's 996. I got the square roots, I think, because it has to do with the liquidity and the formulas from the white paper. But I don't understand why x96. The most recently updated index of the observations array, which is the tick thing and the cumulative price, I think. Probably it has to come from the oracle that I just saw there on top. The current maximum number of observations that are being stored. The next maximum number of observations to store, triggered in observations.write. The current protocol fee as a percentage of the swap fee taken on withdrawal represented as an integer denominator. Whether the pool is locked. So how does the pool lock work? That's what I want to understand. I guess I remember it's from with mutex that it locks, I think, but I'm not I'm not sure how it works with if there's a time frame for people to lock the assets. Actually, it might be a very good idea now that I'm thinking about just deploy everything and then because the reason why I don't wanna uh, invest is obviously because it's gonna cost money for gas and so but it's obviously better to learn by interacting with the thing. So I think it's probably gonna be a very good idea to deploy all these contracts in a testnet chain and then interact with them. So I understand how it works on the investor side, the liquidity provider side. So this is the tick stuff. Call token observations, which I'm also interested in looking at. Lock only factor owner. This is the liquidity logic. Wonder if there's the name of the contract or whatever this is at. UniswapV3Pool. Also, it is this contract. I wonder if I can change the size of these things. And this is also swap math lib. I'm gonna look at this later. It's definitely really complex. After block time stuff. Yeah, maybe I'll open this later, but I think I understand for now. So the lock or unlock comes from this. Whether the pool is locked. Oh, that's why they don't use the re-entrancy attack thing. So this is a different thing. It was first time that I looked into this, I got confused. I thought they were using the mutex to prevent re-entrancy, I guess it also works, but the reason why they are doing is to determine if the pool is locked or not. And where is the oracle coming from? I think I'm gonna... Oh, so... Never mind. I was gonna say that I was gonna open the graph again to see if I can find this oracle there. But I think this is probably the file that has the oracle, which is also interesting to see. But it does work just like a reentrancy attack prevention, whatever you call, where it's just changing the state from locked to unlocked in between the function. Mutually exclusive reentrancy protection into the pool, true from a method. This method also prevents entrance to a function before the pool is initialized. Also prevents entrance to a function before the pool is initialized. I wonder why they put that in there. I'm trying to think about things that you can do by calling a function while the pool is being initialized. Obviously, manipulating the price. There was probably some attack in the previous versions with that. The reentrancy guard is required throughout the contract because we use balance checks to determine the payment status of interactions such as mint, swap, and flash. Throughout the contract because... Oh, okay. I think I understand. Prevents calling a function from anyone except the address returned by UniswapV3 factory. So the factory owner. It's pretty explanatory, self-explanatory. So static call is another one. And maybe it is coming from them. That's lot 0. No, token 0 is an address. So it's probably something from Solidity. It's weird that there's no videos talking about it though. So it looks like this was recently, quote unquote, because it's from 2013, but this was implemented later after this post here and prevents reentrancy attacks. So it makes a call, but it prevents modifications on state. So they are preventing delegate calls. Delegate call is when you call another contract from the initial contracts, I think. I'm gonna look at this later as well. I wanna get to the lock part, or to the minting and burning, so I understand, because that's the main thing that I'm not really sure for now is how they. Because one thing that I was thinking about is if anyone can add liquidity and remove liquidity anytime they want, then it would be too easy to manipulate the price, I think. Because you can just do flash swaps and all of this kind of stuff and remove and add liquidity and then manipulate the price, do arbitrage, and it wouldn't work. So they probably have some prevention for that or some mechanism. I just want to understand the logic for how do you prevent people from doing that. But at the same time, if if you only allow people to deposit and then you have to lock the assets for some amount of time, how do you determine the time? Because if you put a lot of time, then nobody will want to put money in. But if it's a short period, then there's also different problems. So I don't understand how they do that. What's the decision? The problem is that in the V3 is a lot more complicated because of the virtual reserves thing. But I think the logic for minting and burning should be similar on both of them. And to understand as well why this doesn't have the modifiers to prevent people from calling. It's private, but I don't know if this is enough to prevent anyone from updating anyone's position. No, this is the minting problem. The add liquidity function. So this one has a lock. I think I get the logic. It's just gonna do the whole ticks thing and then update the position by calling the other function. Get amount delta does the all the tick logic for the virtual liquidity. I don't understand everything, obviously, because I didn't spend too much time reading, but or thinking about it. But I just want to get the gist of it for now, and so I can continue to try to understand the other one. So it calls with these modify positions parameters. Is the owner, the ticker, lower and upper limits, and liquidity delta. Where does this come from? Comes from the data, probably. Bytes call data. Oh, actually not. It's an object, so it's saying that it is the. Yeah, I'm tripping. So it is the int 256 of the amount to int 128. I don't understand though. So, okay, so I think I get one of the questions that I have, which is they just accept one amount. So you probably only deposit one amount, one coin, and then it converts through this modify position logic, because this returns the amount of both coins that you get. So you probably deposit one amount and then receive two. But I don't get, the only thing that I don't get here is why do this conversion here for the amount and not initialize it as int 128. Don't understand. It probably has to do this with the overflow thing that it talks about here, and that calculation with this special things that they do with the price, cumulative price, and that different variable UQ 112 that they did, but I don't understand really well. Oh, these are the functions. Yeah, the previous ones. And this gets the balance of token 0 using this address. This is the balance before, so it's getting the balance of the contracts, both for 1 and for 0 and 1. And then this is in the callback. But where does this come from? I don't understand how is it possible that it's just the interface though. There has to be the function somewhere. It's probably this one. It calls from the interface, but the actual function is this. What is data here? Oh, data. Yeah, I'm curious to know what this actually means here. What is being passed as data? It's probably the quotes, maybe the quotes and the fees, or something like that. If I had to guess, because I remember looking at in the front end in the interface. Maybe I wrote it down. I'm gonna look at it. Oh, it's also from the interface as well. It's the same. Yeah, so I don't get it. I don't get how it's possible, true. Because there's nothing there on the file. So it doesn't make sense. And then here it adds the amounts. 0 and 1 requires is smaller than balance 0 and 1. don't get this as well. If you're adding the amount 0 to the balance before, how is it possible that it is smaller than the current balance? Doesn't make sense to me. Oh, yeah, obviously, because one of them is gonna be negative, I think. Because you're, unless they have a perfect ratio, but yeah. But then it can be equal as well. Yeah. So if they have a perfect ratio, it doesn't matter because it's gonna make it true. Or basically, when you deposit, it's probably an example, you're depositing 5 ETH into the ETH USDC pool. So immediately the USDC is gonna be higher than ETH because the amounts are gonna be split between ETH and USDC. And then one of these conditions is gonna be negative, which makes this thing true. That's what's going on. The only thing that is unclear to me is I don't understand how is it possible to. It's creating the abstraction of the contract with the message.sender. So, and then it's calling this function, but it doesn't look like there's anything on this function here. Uniswap3 means callback. Yeah, because here is just a function declaration, so I don't understand where's the functionality coming from. Oh, so this is the amount you owe. That's why there's no functionality. It's just registering the amount because you're minting the amount, then it creates the abstraction in the contract that says that you own that amount so you can later burn it, I think. Any data passed through by the caller via the Uniswap call. So it also uses the lock. No delegate call is applied directly via my modify position. So it's pretty similar to the other one, but it only has the lower and upper and the amount. Then calls the thing to modify the position. Then makes it negative. And if either one is bigger than 0, just token, where's the position? This, that comes from this. Oh, and now is accessing the interface through the position here, which is probably going on this call here. And then it's just subtracting these amounts, which are the negative of the amount that is being withdrawn. Hey, it doesn't look like there is anything that prevents people from withdrawing or adding liquidity whenever they want, which is a little bit weird to me. But I guess it works. And it didn't wrote. Uh, obviously is because there was a lot of stuff that I was looking at, and I wasn't sure what exactly I was gonna look at when I was studying the interface. But what I should have done is write down which functions were calling their interface. So for example, the interface file and then the function, and then that pointed to the contract function. So I can create a connection between the interface and the smart contracts. I think the next time that I look into the interface, I'm gonna do that. And that way, because then I'm gonna be able to think about what arguments are being passed here in the front end. So I understand how they are doing this. But I don't think there is a time limit. You can add or withdraw liquidity whenever you want. Which I don't understand how it works exactly because, but maybe it's hard to do that. I'm not sure, but I remember seeing a hack that someone withdraw a bunch of liquidity from an exchange and then they did a flash swap on another place, and then they made an arbitrage, and they just kept doing that until the pool was out of money. But I guess this is prevented now with the cumulative price instead of uh, locking the liquidity. Because then the price is not, it doesn't deviate as much as it would before, I think. So maybe that's why, yeah, maybe that's the way that this was solved, but I don't understand really well. In my mind, it still opens up a little bit for exploitation. Yeah, I'm kind of tired, to be honest. So I think I'm gonna go train, and then after that, I'm gonna work on the Python stuff to read PDFs, and then study a lot of articles that I want to study. And maybe I'll come back today and continue to study this stuff. I think what I'm gonna end up doing though is I'm gonna go back to the interface and then do the thing that I was just talking about, of writing down here the link between the interface and the smart contracts, so I can go one by one, side to side, and see how the front end data is being passed into the back end contracts. But I think I understand now much better the logic as well just from looking at the two contracts I looked into. The other thing that I have to do is to study this other stuff here that I kind of forgot. The interface and the delegate call. Oh, the other thing that I might do actually, yeah, maybe actually I might do that before I even do the interface thing. I think what I'm gonna do is create a different project and then deploy the smart contracts, all of the smart contracts on the testnet, and try to, or maybe I don't need to create a different project. I'm just gonna, let's say, pretend that this is my project, and I'm gonna use the interface to interact with it. I'm gonna deploy all the contracts from all the projects. Yeah, maybe it's better to do a whole different project and put, because I wanna put everything else in the same project instead of having separated like this, where with the Redux multicall, the swap router. Because one of the things that I'm also thinking about and I don't understand yet is what was their logic behind the ABI placements here on the files, the folder structure. I guess they just put everything on this file, but I'm not really sure. Maybe not, as this only has some of them. Yeah, this was the thing that I was thinking about. Which ABI can you use for each of these contracts? Can you use the ERC20, ERC721? Which one do you use for each contract? I think the pool is probably the mix one, which is probably this one. And then why do they have this also? These ABIs here, ENS. I'm not sure if there are any other places that have ABIs here. Okay, here is one. Maybe they have it in all files. Because I remember in the other project that I did, the way that I did the deployment was to put the FS, use the FS module to write the ABI into the file directly. Oh, this was what I was gonna do as well. To open this and see the structure. I guess it's just a normal JS. Yeah, normal JSON. Because the way that I did, remember, I made this equal to a variable so I can access on other files, but it doesn't seem like it's necessary. Yeah, but I think I'm starting to think, yeah, it's probably gonna be a lot better to do what I was talking about, where I'm gonna create a different project though because of the ABIs here. I wanna deploy all the contracts and then figure out how to do it like it is here. Oh, actually, what I'm gonna do is not create another project. I'm gonna deploy the contracts for the testnet, and then I'm gonna delete the files here or move them to another file. And then I'm gonna try to run the thing, and then by doing that, I'm gonna be able to know which ones I need on each file. That's gonna be a lot better, I think, to understand. And then after I do that, then I can play around with the contracts because it's just on the testnet and it's not gonna cost anything. And that's probably gonna be a lot better to understand how it works than just reading because I wanna add liquidity, remove liquidity, and also do swaps. So that's probably what I'm gonna do later. I'm not sure if I'm gonna do that today because I have a lot of stuff, like I said, to do off stream. So yeah, probably gonna come back tomorrow or some other day to continue to do this. So see you then.